So velocity is calculated, stopping potential. Electrons are coming out with zero velocity and wavelength of incident light is 400 nanometer. What is that m into v? Momentum of the moving particle. Maximum kinetic energy is associated with maximum velocity. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. Continuing my discussion on the problems part from the chapter Dual Nature of Matter and Radiations. What is that I have in store for you today? We will be discussing few more problems from photoelectric effect and from de Broglie wavelength. I expect you have gone through the previous session, practice those problems and ready with today's sessions. Remember, exam bells are ringing hard. The first one. The problem says electrons are emitted with zero velocity. Key word to resolve the problem, solve the problem. Electrons are emitted with zero velocity from a certain metal surface. Electrons are coming out with zero velocity from a certain metal surface where it is exposed to radiations of wavelength lambda naught. So, electrons are emitted with zero velocity with a certain metal surface when radiations of wavelength 6000 angstrom is incident on it. I have to calculate the threshold frequency and the work function. So, what is that we have to calculate? The threshold frequency and work function. So, how do I proceed with this problem? The problem says electrons are emitted with zero velocity when radiations of certain wavelength is incident on it. Which means now this wavelength is nothing but lambda naught, which is the cutoff wavelength. Threshold wavelength. So, the first step of calculation, threshold frequency nu naught, which is equal to C divided by lambda naught. Frequency nu is C by lambda. So remember, wherever the electrons are emitted with zero velocity, the corresponding wavelength is the cutoff wavelength, which is lambda naught, or nu naught is 3 into 10 power 8 divided by 6000 angstroms into 10 power minus 10, or nu naught is equal to 5 into 10 power 14 hertz. So on simple calculation, threshold frequency turns up to be 5 into 10 power 14 hertz. Now, I'm also asked to calculate the work function of the metal surface, where I know work function is H nu naught in terms of threshold frequency. Work function phi is H nu naught, or here phi is 6.625 into 10 power minus 34 into 5 into 10 to the power 14. When I simplify this, my answer is in terms of joule, work function. But the nuclear scale for energy, electron volt. So joule has to be converted into electron volt. So in my previous session, we have learned how to do this. So this is divided by 1.6 into 10 power minus 19, which is the charge of the electron. So on simplification, this is nearly 2 electron volt. So this is the work function of the metal. Little bit of concepts, little bit of expressions. Very easily I can solve the given problem. The next problem, pretty interesting. This is a 5-mark question. I will just give you the concepts. I expect you all to simplify and get me the answer. So this is a very important problem which is asked for 5 marks in the exam. Calculate the maximum velocity. The first line of the problem itself is to calculate the maximum velocity of a photoelectron if the work function of the target material is 1.8 electron volt. Work function of the target material is 1.8 electron volt. And wavelength of incident light is 400 nanometer. Maximum velocity ಕೇಳಿದ್ದಾರೆ. Work function of the metal is given to be 1.8 electron volt and wavelength of incident light is 400 nanometer. What retarding potential? My dear students, the word retarding also means stopping potential. Retarding potential, stopping potential is necessary to stop the emission of these electrons. Let us first solve the earlier part of this problem, where I am asked to calculate the maximum velocity. Work function of the target material is given. Wavelength of light is given. How do I calculate the maximum velocity? As usual, it is from Einstein's photoelectric equation. So Einstein's photoelectric equation says energy of the photon is work function plus maximum kinetic energy of the liberated photoelectrons. So energy of the photon equals work function plus maximum kinetic energy. So energy of the photon, since wavelength is given, so hc by lambda, W is directly given work function plus half m v square max, because kinetic energy is half m v square. Maximum kinetic energy is associated with maximum velocity. So half m v square max. The first part of the calculation, hc by lambda. So this is 6.625 34 3 into 10 power 8 divided by lambda. So the wavelength was 400 nanometers into 10 power minus 9. So this is the energy of the photon, which I keep in joule. Why am I not converting this into electron volt? I have been asked to calculate the velocity, whose SI unit is meter per second. Therefore, I am keeping the energy of the photon in joule. Simplify this, you get the energy of the photon. B, work function is given 1.8 electron volt. Now look here, work function is in terms of electron volt. Now energy in SI scale, joule, which means this is 1.8 into 1.6 into 10 power minus 19. So many joule. So on simplification, mass of the electron is known. So substitute here. So this becomes 6.7. So velocity becomes 6 into 10 power 5 meter per second. So when you simplify, see, you're substituting for hc by lambda, w, both of them in joules, mass of the electron, you get the velocity as 6 into 10 power 5 meter per second. Now, how do I calculate the second part? The retarding potential, the so-called stopping potential. The moment I say potential, as usual, the same concept, gain in kinetic energy is loss of potential energy. Elli potential anno term use martare. Use this concept. Gain in kinetic energy equals loss of potential energy. So this is half mv square. I want this v, so mv square by 2a is v. What is m? Mass of the electron. Small v, velocity of the electron, which is already calculated. E, charge of the electron. On simplification, here v turns out to be 1.3 volts. So this is the answer. So velocity is calculated, stopping potential is also calculated. Next one, simple one, based on the concept of matter waves, also called de Broglie waves. Calculate the de Broglie wavelength. I have to calculate the de Broglie wavelength of an electron moving with a velocity 3 into 10 power 6 meter per second. Mass of the electron is 9.1 into 10 power minus 31 kg. So by data, velocity is 3 into 10 power 6 meter per second. And mass of the electron is 9.1 into 10 power minus 31 kg, with which I have to calculate the de Broglie wavelength. Do we have any expression to calculate de Broglie wavelength when mass and velocity is given? Very good. So we have lambda is h divided by mv. What is that m into v? Momentum of the moving particle, product of mass and velocity. So from this directly, h is Planck's constant, minus 34, 9.1 minus 31 into velocity is given. So 3 into 10 power 6. So on simplification, lambda turns out to be 2.46 angstrom. Again, using a basic formula, I have calculated lambda, which is de Broglie wavelength. Where again I have to calculate the de Broglie wavelength. What is this de Broglie wavelength? Wavelength associated with a matter wave. Alva, we told it is the wavelength associated with moving material particle. Calculate the de Broglie wavelength of an electron whose kinetic energy is 500 electron volts. Mass of the electron is given. Again here, energy is given to be 500 electron volt. But see, de Broglie wavelength is in angstroms, meters. So again, I need to convert energy into joule, which is again 500 into 1.6 into 10 power minus 19 joule. Again, the mass of the electron is an established constant. Now, expression for de Broglie wavelength in terms of energy. So we know in terms of energy, lambda is h divided by root of 2m(E)k. Various forms of de Broglie wavelength we have written in terms of energy, in terms of potential, with respect to V, with respect to C. So in terms of kinetic energy, h divided by root 2m(E)k. Again on simplification, 6.625 minus 34 root of 2, 9.1 into 10 power minus 31. So 500 into 1.6. Hope all of you have got your simple calculators. The scientific ones are not allowed in the examination. So lambda is 0.55 angstroms. So this is the de Broglie wavelength corresponding to an energy of 500 electron volt. The same way, an assignment for you all. Again, to calculate de Broglie wavelength, ball has mass 150 grams. 20 meter per second is the velocity. Again, lambda is h by mv. Now this is 150 into 10 power minus 3 kg. Velocity is so much. Substitute, you arrive at the answer. So you have seen in today's session how simple, using some expressions, known concepts, we have solved problems. From my next session, I will be solving problems from the NCERT textbook. Until then, have a nice time. Thank you.